which is just sometimes what happens in geometry. We do constructions instead of warm-ups. I'm sure you're all very disappointed. So what we're going to do is construct and measure some angles first. Here we go. Moron versus moron. Take out your protractor, okay? Husqvarna, maybe a John Deere, what do you want to call it? And you're going to draw an angle for me. So what is an angle? Well, it's the intersection of two rays, right? It's how they intersect. So we're going to draw two rays. Hi, Ray. Yeah. Get it in your warm-up sheet.
Oh, warm-up sheet?
Yeah. So I'm going to draw one ray. Hi, Ray. And then I'm going to use my protractor to draw another straight ray. Again, the key here is that these are straight, not curvy. Any angle you want. It can even be a straight angle, okay? Be a reflex angle. Any angle you want. I'm going to bisect this angle. And bisect means cut in half, right? I'm going to do it without measuring.
What is it?
Oh man, almost exactly 60. I'm usually pretty good at just getting these right on the dot. First 2 hours I had exactly 25 without trying, and exactly 50.
Doesn't matter how long it is.
New personal best. No. Construct your own angle. Okay. Maddie, you need a bigger desk.
Looks like you got a nice cute.
Shut up, Eads. All right. So here's what we're going to do. Get your compass. That's the one that isn't round. Who names these things, right? And you're going to put the pointy part on your vertex that you made, okay? Set your compass up. That way it's not bigger than your rays. So I'm going to make mine a little bit smaller. See how it's not bigger than my ray that I drew? Everybody with me? All right, now you're going to draw an arc, and that arc, you want it to make sure it hits both your rays. Ah, satisfying. She purty. Look up when you're done. So I know you got it.
Got it. That's pretty big.
We don't judge.
I got intention for slamming it on.
Really?
Really.
Should I write one to myself? All right, here we go.
Back in,
Where that arc intersects your rays, put 2 points. And then let's name our angle something. You want to keep it simple? Let's call it ABC. So write that down. This is angle ABC, angle symbol ABC. And if his name is ABC, what do we know about the vertex? The vertex is what?
That's going to be B.
It's going to be B.
C. A.
Now, the red points that I drew can either be A or C. They're interchangeable, right? It doesn't matter. We can read it A, B, C, or we can read it A, B, C. B has to be the vertex. I'm going to put A on top and C on bottom, but they don't mind being either. First one today. All right, so now what we're going to do is take your compass again. And if you want to use the same setting or a different setting, it's fine. Put it on A. And we're going to draw an arc. And again, the idea is we're going to bisect this angle. And the bisection is going to take place somewhere in the middle, right? So you want to make sure that your arc that you draw, I'm going to make this a little bit smaller so I can fit it on my page. The arc that you draw goes through the middle. So see how that's like the middle right there? That's the middle of my angle, it looks like right here. So I have an arc there, that's good. Then keeping that same setting. So don't screw up the setting after you do it, okay? Do the same thing at point C. So I'm going to plop that down. I'm going to draw another arc. And make sure those arcs intersect. That's where the magic happens. So arc 1, arc 2 using the same setting, both starting on A and B, or A and C. Look up when you got it. I know your compasses suck, I'm sorry.
This is trash. Just move.
If it keeps moving, all you got to do is tighten the nut, man.
I don't even.
Yep. All right, phrasing. So where those intersect, we're going to call that point D. And the jokes just keep coming. And they don't stop coming, and they don't stop coming. Anybody excited for Shrek 5?
Yeah.
Smash mouth, right? All right, so we're gonna call that point D.
Wanna go on Shrek?
Now we're gonna connect D and B.
Wanna go watch Dragon Ball? Yeah.
There we are. We have bisected the angle. So that means that we've cut it in half, right? So now we have a half up here, and that's gonna be the same as this half down here. The tick marks tell you they're congruent. So, didn't matter what the angle measure was. We didn't have to measure it. We found the bisection point. Which means, when you're drawing and you want to make a diagram, you can just say, look, that guy bisects this angle, so says me, right? You don't need to actually bust out all the tools. We proved that you can do it, so let's just say you did, right? Let's not and say we did. So if I draw another angle, I can go like this and be like, hey, that's a bisector. These two are equal. And because I said it is, right? I could have done it exactly, so let's just pretend we did. Yay, saving time. So you're going to do this on your own now, okay? So let me show you what you need to do. And then I'm going to show you something else, and you're going to forget about it. I'm going to go back and show you again, okay? So you get a couple of looks. So number one, first thing you do is draw an angle, right? Make sure your angles are straight. The lines are straight for the rays, right? Then you pick a setting, and you draw an arc. It should hit both rays, right? Then you plot those 2 points. So do this, plot your points. Step 2, go to A, pick a setting. Go to C, keep the same setting. Where they intersect, that's D. Draw your ray. You bisect in an angle. Okay, I'm going to show it to you again. So if you're about 50% right now, we'll get the other 50% in the back half, all right? Next thing we're going to do, our first construction that we ever did in here is coming back, okay? So we're going to draw a segment, and we're going to bisect a segment. We've done it once already, but we'll do it again for good measure. Ha 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 ha, measure. All right, so we'll call it AB. We're going to cut that segment in half. Doesn't matter how big it is, how small it is, you can cut any segment in half. Just a thing, okay? So what we're going to do is we're going to take our old compass out, and the setting for your compass needs to be more than halfway between A and B. Is this starting to ring a bell? More than halfway. Right? Now that you've done that, draw an arc. Sitting on A, and make sure it's a big arc. Like half a circle almost. It's not a very good one, but it'll work for today. Keeping the same setting, repeat for B. So same setting is the key here. I love this compass. Everyone should have one of these, like in their car, ready to go, just in case you got to stab a tire, right? Or do some geometry. I do both. It's not slashing if you're poking. Okay? All right. That's not against the law. Poking is not against the law. All right, so here we are. Where those intersect, we'll call them C and D. And guess what we're going to do? We're going to connect C and D. And that's going to be our bisector. So it just cut AB in half. Like your favorite horror movie. And not only that, but AB also cut DC in half. So this is also cut in half. Which means this bisects AB and AB bisects DC. They bisect each other. Not only that, but they hit each other at a 90-degree angle. The hint here is purple. What do we call it when two lines hit each other at 90 degrees? The hint is purple. You want to say parallel, but it's not.
Purple.
Nope, close to purple though.
Pink.
Nope, colder. This is a purple what? Pen. A perp pen, if you will. Perpendicular, very good. I could have broken it down further, but I decided not to. So yeah, perpendicular. That's what it means when it hits at 90 degrees. So let's write what we know. For this one, we know that AB is a perpendicular bisector. That's the perpendicular symbol, right? That little upside down T. Of CD. So AB is a perpendicular bisector of CD. What does that mean? It cuts CD in half, hits it at 90 degrees. Instead of writing that twice, I'm going to do an arrow going both ways, meaning that you could read it backwards. CD is a perpendicular bisector of AB, right? They both perpendicular bisect each other. What do we know up here? Well, we constructed a bisector, right? An angle bisector. So let's write let ray BD. Only one arrow on that because it's a ray. Hi, Ray. Bisect. What angle did we end up bisecting? BD bisects what angle? What angle does it cut in half, Mr. Eads? What's the name of the angle that we just cut in half? This is a ray. What angle does it cut in half? ABC, right? Mm-hmm. So let this guy bisect ABC. Okay? So that's what happened. When we construct something, what we're really saying is let it happen. Let it be, right? Let this be the bisector. We could draw it all out, but why? Just let me tell you it is, okay? So let it bisect ABC. Now, what does that tell us? What does that tell us then? If this red ray bisects this angle, what does it tell us about these two angles? Super easy. You're probably thinking there's no way he's asking that, but I am. So if this guy, red ray, hi red ray, bisects the blue angle, which is what we said it does, right? What does that tell us about these two angles here? They're equal. Another word for that is, starts with a C, congruent, right? Figures are congruent, numbers are equal. So we know that angle, what's this top angle here called? What's the name? A, B, D. You can see what I'm doing, right? So angle ABD is congruent. That's an equal sign with a little tilde on top, right? To what other angle? What's the other angle it's congruent to? ACD? DBC. Now, Mr. Eads, you're correct. However, there's a better answer, angle CBD. Golden opportunity there, man. You whiffed on it. CBD. Not only is it fun to say, but it also matches up really nicely. See how the B's are both in the middle and the D's are both on the end, right? If we're showing something's congruent, it's nice when the letters match up as most as possible. So ABD, CBD. Would you be wrong if you wrote DBC? No, but you had missed a golden opportunity. Questions, comments, concerns other than for my mental well-being? Here's what you're going to do now. Nope, I can't. You're going to use mine. Here you go. Don't break it. Mucho cuidado, por favor. All right, so here's what you're going to do. Draw an angle, bisect it. Do it now. After you're done, on the back of your warm-up sheet. After you're done with that, bisect the segment. If you need help, I will come around and I will show you the way, which is also the song of the day. Show You the Way by Thundercat. The man is named Thundercat. It's one word. He's probably the greatest bass player alive. Might be the greatest bass player to ever live. He has a 12-string bass, which means everything you hear pretty much is him playing the bass. It just sounds like multiple instruments. On the song to join him is the legendary Kenny Loggins, who is the white guy you think of when you think soul music, and Michael McDonald, who's the lesser-known white guy you think of when you think soul music. Kenny Loggins is the guy that did Footloose, the soundtrack, basically. He sang the lead song. No, it was not Kevin Bacon. The song is called Show You the Way. It's a good song, I think. It makes you feel like everything's just going to be all right. Thundercat is played with a lot of different artists, including Flying Lotus. If you want some like hardcore sick, like rap meets jazz, check out Flying Lotus. Blow your mind.
Your heart is struck, caving, trying to
hear something more hardcore, check out Flying Lotus.
Need a bigger paper.
That bass line is yeah, just all over the place. What's up, Doc? Congrats. That's it. It's your birthday, right? Happy birthday.
Those are just, those marks that
Thanks.
that just indicates that those two segments are congruent.
Oh,
Okay.
they're not needed.
That's not part of the construction. That's what you do after the fact.
Thanks for the assist. All right. If you're done with that, great. Okay. If you're not, finish it up real quick and then hang on to it because it is your warm up. We'll have one more this week, maybe on a Thursday. I don't know. I feel like I'm cutting you guys short, right? We're not gonna have one tomorrow because we get star testing. Woo! The reason for the season is why I became an educator. It's what we're all about here. Okay. It sounds more fun than it is. Well, you know better than I since I've never done star testing. I just know it's another. Hey, that's not the word we use in here. Even for testing. Thank you very much. Very few words I have rules about, but that's one of them. All right, so construct and measure angles. We done it. We done did it. Now we need to talk about regular polygons, right? That's what we're going to do. And the way we're going to do it is with the worksheet, the worky sheetie I just gave you. So if you pull that big, thick packet out again, she's thick, but she only has a few problems, okay? We're going to do one of them together. Polygons and perimeter on the coordinate plane worksheet. We're going to go step by step through here. We're going to talk about all the things that we need to talk about, okay? So it says write the name of each polygon. Stop right there. It begs the question, what's a polygon, right? Well, let me tell you what it isn't. A polygon is not something that looks like this. Okay? The reason is that we have three segments here, and they don't all intersect at their endpoints. See how we have endpoint here and an endpoint there? We have them intersecting at a point that isn't an endpoint. In other words, we have an open end, right? Not allowed to have open ends. Not allowed to have intersections that aren't at endpoints. So even if I close this up, right, like this, that is not a polygon. It's a fish, right? We've got two different polygons right here, 1 and 2, but the whole thing is not a polygon because it intersects at a point that isn't an endpoint. You picking up what I'm putting down here? Okay. Also, this would not be a polygon because it doesn't intersect at the endpoints. Those two are left open, right? That's not cool. This would not be a polygon because it's a circle. It has no sides. So really we have two things. Need sides, okay, so no circles. And those sides need to intersect at the endpoints only. So good, 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 nope. That's not an endpoint. Cool? That's a polygon. Poly meaning many, gon meaning, I don't know. I actually don't. Look that up. I'm not sure. Tell whether the polygon is convex or concave. Let me break it down for you. Convex is something that doesn't bend inward, whereas concave does. So let me illustrate it like this. Here's a side of a mountain, okay? Concave caves in. That's a concave polygon right there. So concave. That's one way to think of it. Another way to think of it. Look at the internal angles. Internal meaning inside, right? Like inside voices, internal voices, which is what I hear all the time, but I just ignore them for the most part. If you look at the internal angles, the ones on the inside, right? We have a reflex angle on the inside. That's concave. If there's a reflex angle on the inside, that's concave. That's the one where you hyperextend your elbow, right? Reflex is bigger than 180. So anything bigger than 180 degrees, right? If I extended that line out, that would be a 180 degree angle. Well, it's more than that, isn't it? So that's concave. Reflex is concave. Another way to think of it is if you extend the lines like this. See how that line would extend into the interior of the polygon? See how that goes inside? So if it goes inside when we extend it, also concave. So what is convex? Well, convex is the opposite of that. Convex is like your contacts. You'd rather put something convex in your eyes than you would concave. That's going to hurt when it goes in, right? But if we have convex, everything is outward. That's the best I can do there. None of these angles are bigger than 180. That's smaller than 180. That's smaller. That's smaller. That's smaller. That's smaller. Some of them are bigger than 90. But they're not bigger than 180. So let's figure out what this guy is. Right? What is he? Convex, right? Because this is not bigger than 180, is it? No. It's like a little bit more than 90. This is not bigger than 180. Again, a little bit more than 90. That's less than 90, so that's not bigger than 180. That looks a little bit more than 90, so still not more than 180. And that looks a little bit more than 90. right? So none of those are bigger than 180. If you need to, draw a straight line and remind yourself that that's a straight angle. That's 180, right? So that's smaller than 180. Draw a straight line. That's smaller than 180 because 180 would be this. Or draw the lines out and see if they go inside. If we extend these guys, none of them would go inside. This guy would stay on the outside, that would stay on the outside, that would stay on the outside. None of them go in. As opposed to number 3, if I were to extend that line, see how that line would go into the inside of the polygon? If I extend AB, it would go internal, right? Also, this guy, what kind of angle is that? Reflex, right? Over 180 on the inside, right? So that's going to be convex. Or concave, I should say. Caves in, right? There's the cave in right here. All right, so it says name it and tell whether it's convex or concave. So we know that this one is convex. Now we need to give it its full name, which has to do with the number of sides, right? So we're going to list some popular names of different sided polygons, like Becky and Steve and John, right? Okay, this is the Becky of polygons, triangle. You've heard it a million times, right? Everything has this name. And why we call it a triangle? Because it has 3 angles. Also, it has 3 sides. Turns out, the only way to make a 3-sided polygon is to make a triangle. That's it. There's only one way to connect 3 sides, if they have to connect at the end point, right? Only one way. So we call it a triangle. It's very specific, right? Now, when we get to 4 sides, there's lots of ways to draw that. We can draw rectangles, we can draw squares, we can draw rhombuses, we can draw lots of things, right? Trapezoids, parallelograms, you name it. A kite. So we need a catch-all term for anything with 4 sides. And so we call that a quad meaning 4, drillateral. Now, you know what quad means probably, because I just told you, and you may have known it earlier, meaning 4, right? Quad, like a 4-wheeler, right? Lateral means side. It's a Latin term for side. So when we talk in like anatomy, the lateral part of a person, right? We're talking about the side of a person, or the side view, the lateral view. If you're a football fan, right, you run a lateral, it's when you throw a pass to your side. Anything forward, right, that's a forward pass. Lateral means to the side, and sometimes that's legal and sometimes it isn't. What is a catch? Quad is 4. Next one is pentagon, which is 5 sides, which supposedly is like the devil's thing, the pentagon, right? Which I think is silly because isn't like 6 supposed to be satanic? And also 6 is hexagon. It isn't a hex supposed to be satanic? I don't make the rules. Yep, that's right. I just worship the cult that follows them. All right, so pentagon, hexagon, 7 side. I think septagon is the term, but everybody just says 7gon. That's what we do when we don't know what to call it. 7gon. The ones I've written out for you, I need the exact names. Don't call a triangle a 3gon. I swear to God. Okay? Especially on the exam. So that's 7 sides. And 8, everybody loves the 8. It's the stop sign. Or if you like UFC fighting, the octagon, right? 9gon is 9gon because it's fun to say 9gon. Next is 10gon, but we have a name for that. It's called a decagon, and that makes sense because December is the 10th month of the year, and decagon has 10 sides. 11, 11gon. 12 is a dodecagon because do means 2, and dec again, like December, means 10. So 2 plus 10 is 12. Those are the big ones, okay? I don't need 7gon, I don't need 9gon, I need all the rest understood. So when I tell you what if I say, imagine a dodecagon, you're thinking of a 12-sided figure, right? That's what I need you to be able to do. So which one is this? It's convex, but it's a convex what? Pentagon, because it got 5 sides, so it's a pentagon. And then it says mark congruent segments. So the marks are little tick marks, right, that we're gonna make. Congruent means same length, or same everything, really. But segments only have length. So we only have to check length. How are we going to know which ones are the same length? Are we going to measure them? No, we are men of science. We have methods. We have the technology. What we're going to do is use Pythag, otherwise known as the distance formula, right? Plug in your points. Or, what if we just use Pythag? Pythag's easier, right? Make yourself a triangle, connecting those 2 points. The bottom part between B and C is 4, and the vertical part between B and C is 3. So if you want to know how long BC is, you just need to know what the hypotenuse is of that triangle, right? Luckily, we have Pythag. Pythag says 3 squared. What's 3 squared? 9! plus 4 squared, right? That's the other guy. What's 4 squared? A fun game to play outside. Should equal our BC, right? What's 9 plus 16? The only thing funnier than 24. 20. 25. You've never seen SpongeBob where they go to boating school together, he and Patrick? And then Patrick gets him in trouble? Because they're like making jokes in the back of class? 24? Then he says 25 and it's even funnier? Okay. Root 25 is 5. So that side length right there, BC, is 5. So if we find another one that's also 5, guess what? They're congruent. Let's go randomly choose another one. How about ED? Looks like ED is 3 vertically and is 4 horizontally. There's our right triangle. You could have also drawn the triangle on the outside. It would have worked the same way. Guys, if one leg's 3 and the other leg's 4, what's the hypotenuse? 5, right? Just like the last one. 3 squared plus 4 squared is 25. Root it and you get 5. 3, 4, 5 is a Pythagorean triple. It's 3 nice numbers that all work on a right triangle. There's infinitely many combinations, but only some numbers work. So these guys are congruent. So we're going to draw a line here and here to say that they're congruent. Now, spoilers, none of the other sides are congruent, but we need to find the perimeter, so let's find the other side lengths. So here, between D and C, there's a line. 1, 2, 3, 4, 5, 6 vertically. And it looks like across we're 8. Oh man, it's not a 3, 4, 5. Bummer. Everybody, what's 6 squared? 36. What's 8 squared? 8 times 8? 64. Pick it up what's on the floor. That's what we learned. Or you can know 8 times 10 is 80. That's 2 8s too many. Subtract 16, you get 64. Root 36 plus 64. Guys, let's do this in our heads. What's 6 plus 4? 10. So we have 10. What's 30 plus 60? 90. So 90 and 10 makes root hundo, which we know is 10, right? 10 times 10 is 100. So this side length over here is 10. It is a nice right triangle. Hooray. Check it out, guys. A 3, 4, 5 triangle is the same thing as a 6, 8, 10 triangle. All I did was multiply the numbers by 2. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. As long as you do it to all the sides, it's fine. It's like algebra, right? You do it to one side, child abuse. You do it to all the sides, that's algebra. 3, 4, 5 is the same thing as 6, 8, 10. It's just twice as big. Another right triangle that would work would be 15, 20, 25. Just multiply everything by 5, right? So we have 10 here, a 5 there, a 5 there. They're not congruent here and here. How long is AE? How will we figure that out? Close. It's 4. You just count the squares, right? Hooray. Could you have plugged those into distance formula and got that answer? Yeah, but good God, why? Right? AB, let's figure that one out. We need to draw a right triangle so we can do Pythag. Looks like it's 4 across, and it looks like 1, 2, 3, 4, 5, 6 down. Ah, bummer. That's not a nice right triangle. Right? We have 6 here. That should be an 8 if it's a nice right triangle, and it ain't. So let's figure it out. We have to do 6 squared, which we already know is what? What's 6 squared? 36. And 4 squared, which we already know is a fun game to play outside. What's 64 and 16 added together? Well, 64 plus 6 is 70. 70 plus 10 is 80, right? So we get 80 here. Root 80. Agree or disagree? Why do you disagree? Tucker's paying attention. 6 squared is 36. Nice job, kid. 52. Root 52. A much more fun place to drive than root 80, I think. Right? Just in my opinion. Root 52 is how long that is. Now, that's not a nice root. Bummer. Question. Which is bigger? Root 52 or 10? Why 10? You're right. Why? How do you know 10 is bigger than root 52? Has he got a calculator in his head? He knows root 52 comes out to blah, 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 blah. No. Yeah, but I could have really big decimal. I could have 1000.5. That's bigger than 10.
Yeah, but that's not.
That's not what root 52 is, right? How do you know it's smaller than 10?
Because it's
What's root 64? 8, right? And that's smaller than root 64. What's root 100? 10, right? What's bigger, root 100 or root 52? Root 100. So root 52, whatever it is, it's something smaller than 10, something smaller than 8. Is it bigger than 7? Is root 52 bigger than 7?
yeah.
Root 49 is 7, right? Is root 49 bigger or smaller than root 52?
It's bigger.
Root 49 is bigger than root 52?
49 just seems like good.
It seems like it should be bigger than 52. Yeah, it has a certain ring to it. Nope, root 52 is bigger, so it's slightly bigger than 7. Anyway, we need to find the perimeter. So perimeters add up all the sides, right? So we've got 2 5s, we've got a 10, we've got a 4, and we've got a root 52. Now, just like in real life, all you can do is what you can do, right? Can't do any more than what you can. So let's add this up. P is 5 plus 5. What's 5 and 5? What's 10 and 10? What's 20 and 4? So we have 24 plus root 52. He's on fire. I need a button to press for that, seriously. The entire NBA Jam, like, announcer, like, I want that on dial. The Iceman from downtown. So that's the perimeter. We did all the stuff. Tell me whether it's concave or convex. Tell me what kind of shape it is, what kind of polygon, right? Find the side lengths, add them up, give me the perimeter. Find the ones that are congruent. Let's talk about what regular means, okay? Metamucil, get your fiber. Look at number 6, back page, last page. Regular means 2 things. 1, it means equilateral. And you've heard equilateral before, like an equilateral triangle. Lateral means side, equal means equal, equal sides. It also means equiangular. What do you think that means? Equal angles. So to be regular, it has to have all the same sides and all the same angles. So it says draw a regular pentagon. So it has to have all the same sides, all the same angles. If I asked you to draw an equilateral triangle, I wouldn't ask you to like measure it and make sure it was, right? I would just do this. The sides are the same, so says me. The angles are the same, so says me. So draw me a convex, meaning it doesn't bend inward, pentagon. And tell me all the sides are the same and all the angles are the same. Make it so, right? You gotta measure it. Don't bust out the protractor. 7, can you ever have a concave triangle? If yes, draw me one. If no, conjecture as to why that might be impossible.
You said no though already.
Self-development, 2 points. Prove that a polygon cannot be both regular, remember that means equilateral and equiangular, and concave. So it can't have all the same sides and the same angles and bend inwards. My hint to you. Again, self-development's 2 points. Get them where you want them, right? You need 10 by the end of the semester. I don't care whether you do this or not. What do you notice about the angle relationships as you go from convex, right? Convex to concave. What happens? My hint, look at the internal angles. When we have something that's concave, we have a reflex angle on the inside, right? Now, we know that regular means all the angles on the inside are the same, right? So one of them has to be reflex. They must all be reflex, right? Is that possible? And if not, tell me why. Does the number of sides matter? Meaning if you prove it for a quadrilateral, hey, I drew it with 4 sides and it doesn't work. Does it not work for everything? The answer to that better be yes, otherwise you got to prove it for every single polygon, right? How many polygons exist in the world? Infinitely many. There's a 5-sided one, a 6-sided one, a 7-sided one, right? See you guys next time.